Lesson 4.7, Inverse Trig Functions. In this lesson, we're going to talk about the domain and ranges for our basic trig functions and how to restrict those so then we can work with the inverse trig functions. To start this lesson, a little background information. Recall that we use the vertical line test on a graph to determine if a relation is a function. If it crosses through at only one point, that represents that the relation is a function. We use the horizontal line test to determine if a function has an inverse that is also a function. If we look at the basic graphs for sine and cosine, it makes that wave pattern. So if we were on the whole domain for sine and cosine, those would not pass the horizontal line test. That is why we have to restrict the domain on those functions, restrict the x values. That way we can come up with inverse equations, inverse relations that are also functions. Now we're going to take a look at the domain and range of our three basic trig functions and the inverses for those functions. When we're talking about the sine function, the normal domain is negative infinity to infinity. We restrict that domain to go from negative pi over 2 to pi over 2. Our range is still negative 1 to 1. We restrict this domain so that we can come up with the inverse, the arc sine, also denoted sine to the negative 1, that denotes the inverse. We also restrict the domain on our basic cosine function. When we're just dealing with cosine x, our domain is negative infinity to infinity. We restrict that to 0 to pi. That way we can come up with the inverse, the arc cosine function, in which the domain and range just switch between the basic cosine function and the inverse cosine. Then the last one, we have the tangent, which we restrict the domain to negative pi over 2 to pi over 2. The only difference between the domain for the tangent, the restricted tangent, and the restricted sine is that the endpoints are not included. The range is all real numbers. That's what this R denotes, all real numbers. The domain and range just flip between the restricted tangent and the arc tangent. You need to know the domain and range for these three main trig functions and the inverses. Before we get started going through a few examples, we need to quickly talk about notation, because in mathematics we have a lot of notation that is similar but they have different meanings, and that arises in this lesson. So on the left we have x raised to the negative 1 power, which we would rewrite as 1 over x using exponent properties. That's referring to reciprocals. We also use that negative 1 exponent power when denoting the inverse to a function. So right now that negative 1 on the right side, that is applied to the function for sine. It is not applied to the variable, so we would not rewrite this as 1 over sine x. This denotes that this is the inverse function for sine of x. Now we're quickly going to review the unit circle before we go into evaluating inverse trig functions. Recall that the x value of the ordered pairs are referring to the values of cosine. The y values of the ordered pairs are referring to the values of sine. If we're looking for the values of tangent, we don't see that directly on the unit circle itself, but we can recall that tangent of theta is equal to sine theta divided by cosine of theta. So if I was looking for the tangent of pi over 6, I would have to take the sine value at pi over 6 divided by the cosine value at pi over 6. So I would take 1/2 divided by radical 3 over 2 to find the value of tangent. Example 1, we want to find the value of the inverse sine of 1/2. So we're looking for the value of theta that is going to give us a sine value of 1/2. So we're looking for the value of theta that gives us a y value of 1/2. We have to recall that the range for the inverse sine function is negative pi over 2 to pi over 2. That means the values we're looking at are going to be on the right portion of our unit circle. If I started at 0 and went clockwise, this would be negative pi over 2. So I'm going from negative pi over 2 to pi over 2. Those are the values I'm looking for. So where in this section, this region of the unit circle, do I have a y value of 1/2? So if I look in the first quadrant, I have a y value of 1/2. The y value is referring to the sine. So my answer, I'm looking at that theta value, is going to be pi over 6. Now going to example 2, in this one we want to find the inverse sine of negative radical 3 over 2. Again, our range is still going to be negative pi over 2 to pi over 2. So we're looking at the right portion of our unit circle. We're looking for where the y value, the value of sine, is equal to negative radical 3 over 2. So we have to go down to the fourth quadrant, and that occurs at 5 pi over 3. We can't have an answer of 5 pi over 3 though, because that does not fall in the range between negative pi over 2 and pi over 2. So we have to think of coterminal angles. If I subtracted 6 pi over 3, I would get negative pi over 3. So looking at the unit circle, if I started at 0 and went clockwise, negative pi over 3 gets me to the same point as 5 pi over 3. Negative pi over 3 lies within the range for the inverse sine function, so that is our final answer. Example 3, we want to find the inverse sine of pi over 2. In this problem, we actually aren't going to come up with an answer. We have to think about the domain of the inverse sine function, which goes from negative 1 to 1. And if we look at the value of pi over 2, that is going to be outside of that given domain. So the answer for this would be does not exist. Example 4, now we want to find the value for the inverse cosine of negative radical 2 over 2. The range for the inverse cosine goes from 0 to pi. So we're in the upper half of our unit circle looking for these values. So we're looking for where the x value is equal to negative radical 2 over 2, which occurs at 3 pi over 4. So the value for the inverse cosine of negative radical 2 over 2 using the unit circle, we determine it's 3 pi over 4. Example 5, now we want to find the inverse tangent of radical 3. So since we can't determine directly from these ordered pairs the value of tangent, the x-coordinate refers to cosine, the y value refers to sine, we have to use that quotient property such that if we take sine divided by cosine, we get the tangent value. So the range for tangent is negative pi over 2 to pi over 2, so we're going to be on the right portion of the unit circle. So we're looking for the ordered pair such that if we took the value of sine, the y value, divided by the value of cosine, the x value, if we divided those two, we would get an answer equal to radical 3. If we look in the first quadrant, we have 1/2 and radical 3 over 2. So if we would divide those two values, if I would take radical 3 divided by 2 and divide that whole thing by 1/2. Now if we're dividing two fractions, we just multiply by the reciprocal. So I could think of this as radical 3 over 2 times 2 over 1 and ignore the second fraction. 2 divided by 2 cancels out, so I'm left with radical 3 over 1, which will just simplify down to radical 3. So my answer for the value of the inverse tangent of radical 3 is going to be equal to the theta value of pi over 3, and that value is within the range of negative pi over 2 to pi over 2. In this last example, we're taking the compositions of a trig function. We have the sine of the inverse sine of pi over 4. Whenever you're taking the sine of the inverse sine, it's always going to simplify down to whatever your value is on the inside. In this case, it's going to simplify down to pi over 4. So the sine and its inverse simplify out. We're just left with what remains on the inside. Here's a general rule of thumb to follow when trying to simplify down these compositions. If you're taking the sine of the sine inverse, the cosine of cosine inverse, the tangent of tangent inverse, that is always going to simplify down to what's left inside. if we're taking the inverse sine of sine, or the inverse cosine of cosine, or the inverse tangent of tangent, that will simplify down to what's on the inside only if that value of x is within the restricted domain for our trig functions. A little extra credit opportunity for those of you that actually listened to my whole video. If you write down on a sticky note, hashtag I love math with your name on it, and turn it into me, don't let anybody else know, turn it into me, I'll give you a bonus point. This is only going to work if you don't tell your friends what's going on. I want to see who's actually listening to my videos.